All right, so we're going to go ahead and move on and do this last section in Unit 5, which is all about applications of quadratic functions. Now, don't let the application part scare you, okay? This is everything we've done with quadratic functions. It's just we're getting the information or the formula or the function itself from a word problem, okay? So don't stress out because it's word problems. You can do this, okay? All right, so here's what we're going to look at doing. Determining the max and min values. Okay, it's very important. Anytime you see max, min, or largest, smallest, okay, that should be spurring you on to think vertex. Okay, maximum and minimum values only happen when we have a vertex. Okay, and vertex, right, is that highest or lowest point on the parabola. So anytime we're talking about a vertex, we should be thinking negative b over 2a and f of negative b over 2a. Okay, and we can't calculate the vertex unless we have a quadratic function, meaning we have something that looks like f of x is equal to ax squared plus bx plus c. Okay, we have to have an x squared type function in order to calculate our vertex. Okay, the other thing we're going to look at doing is finding x and y intercepts, which I know we did this in the last section when we were graphing quadratic functions, but I want to show you a couple where we don't necessarily have to have it written in vertex form, just a little refresher on finding x and y intercepts, and then also modeling projectile motion. Okay, so with quadratic functions, we're either going to be looking for that vertex for that maximum or minimum point, or we're going to be giving some kind of output and solving our function for our input. Okay, so when we go through these problems, be thinking about what is it giving me, was it not giving me, what am I solving for? Okay, so let's look at this first one. This first one says a farmer is building a fence to enclose a rectangular area consisting of two separate regions. The four walls and one additional vertical segment to separate the regions are made up of fencing, as shown below. If the farmer has 162 feet of fencing, what are the dimensions of the region which enclose it? Let's go ahead and look at this. So the first thing that I see is I see the word fencing. Anytime I see the word fencing, you should be thinking perimeter, right? Because that's what we do with fences. We put them around something, right? Or in this case, we're putting it all the way around and we're putting it in this vertical segment. So if I want to calculate how much total fencing we're going to be using, I'm just adding up all the edges that I am fencing. So we can think of this as we have a length here, a length here, and a length here, right? And then we have a big width all the way across the top, and we have a big width all the way across the bottom. Okay, so they tell us that we have 162 feet of fencing. So that right there is telling us our perimeter. Okay, perimeter. So perimeter means we add all those edges up. So our perimeter is equal to, notice we have 3 lengths and 2 widths. So 3L plus 2W, right? Adding them up, W plus W and L plus L plus L. Okay, so that gives us our perimeter, and our perimeter is how much fencing we have available. So it told us that's 162. So I'm just going to write in, we have 162 that's going to add up to this 3L plus 2W. Okay, so that's fantastic. Yay, we found perimeter. Okay, but we have a little bit of a problem because what it's asking us for is what are the dimensions of the region which enclose a maximal area. So anytime you see the word maximal, you should be thinking vertex. Okay, so I'm going to come over here and just say this should make us think vertex. Okay, and vertex, remember, we calculate by doing negative b over 2a, and then we plug it back into our function, negative b over 2a, right? So in order to calculate any type of vertex, I need to have a quadratic function, right? I need something that looks more like this. I can't do negative b over 2a when I just have l's and w's, right? That doesn't make any sense. I need something squared, a regular something, and a constant term, right, to figure out what my a and b are. So I need to figure out another way that these letters are all related. So yes, we have perimeter, which is adding things up, but notice here it says maximal area. So that's your hint right there. Okay, so we have a formula for calculating area, right? The area of this is just length times width. So I'm going to write down here that in order to find our area, we just do length times width, right? Or in other words, A is equal to L times W, okay? So when we multiply, that might get us something squared, okay? Now, L and W are two totally different variables, and I can't really do a whole lot with this. So what I'm going to do is I'm going to take this other known relationship, and I'm going to try to figure out what L or W is so that I can plug it into my area formula, okay? So let me show you. Hang with me, okay? So I'm going to solve for L. It really doesn't matter which one you solve for, but I'm just going to solve for L. Why not? So to solve for L, I'm just going to say solve for L so we can express the area in terms of W, okay? So if I can solve this for L and I know what L equals, then I can plug the L in over here and I'll have a function, an area function that just has W's, right? Or you can solve for W and plug it in and have a function of area that only has L's. Doesn't matter which one, I'm going to solve for L. So if I solve this for L, the first thing I need to do is subtract that 2W, right? So that I just have that 3L all by itself. So I'll have 3L is equal to the 162 that was already on the other side minus the 2W that I get from moving it over, minus 2W. Okay, and then I just need to divide that 3 off. Now, that doesn't come out super pretty, so I'm going to go ahead and just divide it under each individual little term. Okay, so this tells me that L is equal to 162 divided by 3 comes out nice. It's 54, right? But my next term doesn't come out so nice. So I'm just going to go ahead and leave it as negative 2/3 W. Okay, so now I know what L equals, right? I know what my length looks like. So I'm just going to take that and plug it into my area function. Okay, so I'm going to write it like this. Plug in for L. Okay, so I can rewrite my area function as putting this mess in for L. So I'll have 54 minus 2/3 W times the W that was already there in my area formula, right? Okay, so you may not think this is looking better, but it is, because now notice we have the area is equal to this, given that we have a width to plug in, right? So I'm going to go ahead and just distribute this W. So this tells us that our area is equal to 54W minus 2/3 W squared. So yay, we have a squared term. So now that we have an area and we have a squared term, we know this is a quadratic equation or quadratic function representing the area if we're given a width, right? And we're looking for the maximal area. So that's exactly how we can now use and calculate our vertex. So I'm going to rewrite this in the right order so that my W squared comes first so that we don't mix up our A's and B's. Okay, so really what we have is we have a function of area, and I'm going to go ahead and write it as a function. So my area function evaluates a W, right, or a width, and we would plug it into negative 2/3 W squared plus 54W. So in this function, we're plugging in width and we're getting out area, okay? So in order to figure this out, what we're trying to figure out is what are the dimensions that would give us a maximum area. Okay, so we first need to figure out what our width is, right? That's one of our dimensions. And using our vertex formula, we can find width by doing negative b over 2a. Okay, so I'm going to go ahead and say in order to find this, we do negative b over 2a. So in my equation, my function that I just came up with, my b is 54. So if I do negative b, I'm going to do negative 54 over 2 times my A, which is negative 2/3. Now, I showed you this in the last video that I did, and I don't have my calculator, of how to plug this in to your calculator using the fraction button. Okay, so on your calculator, I would go ahead and do 2 times negative 2/3 and enter negative 2/3 with your fraction button, okay, and figure out what that equals, and then you can do negative 54 divided by it. Okay, now because we're actually looking for dimensions, we don't want this left in a weird fraction. We're going to go ahead and get a decimal answer. So when I calculate this and plug it into my calculator, I should end up with 40.5. Okay, so what we have found so far is that our width that would create a maximum area would be 40.5. Okay, and our width, our length and our width, notice we were talking about fencing, and our dimensions are in feet. So what this tells me is that my width is 40.5 feet. Okay, so that's one dimension. Now I need to find the other one, because remember, this problem, what we're looking for is what are the dimensions. So we want to think about, where do I need to plug this thing back in so that I find what I'm looking for, right? Now, a lot of times whenever we're dealing with our vertex formula, right, whenever we find that first value, we just plug it back into the function, correct? But we don't want to do that here, because our function represents plugging in a width and getting out an area. Now, we are trying to find the maximal area. We're trying to create the maximal area, but we're not actually interested in what that maximal area is. We're interested in the dimensions that create that maximal area, right? So now that I know what the width is, I'm not actually going to plug it back in, because that would give me area, which I don't care about. What I care about is finding the length. So now that I know what the width is, now I just need to come back over here and plug it back into this equation so that I can find my length. Okay, so I'm just going to say plug back into perimeter, oops, I misspelled it, perimeter formula to find L. Okay, and it doesn't matter if you plug it back in way up here at the original, or if you plug it in where you have it already solved for L. I'm going to plug it in right here because, well, it's already solved for L. Okay, so, and I'm going to come up here in this open space because I'm kind of running out of room. So we found that L is equal to 54 minus 2/3 W. And now we know what W is. So we're just going to plug in our 40.5 for W. So that means that L is equal to 54 minus 2/3 times 40.5, right? And then in our calculator, we should be able to multiply this out. So we'll end up with L is equal to 54, and this actually comes out really nice, to negative 27. And then 54 minus 27 gives us 27. So that means that our length is 27 feet. Okay, so just to go over what it is we just did, right? We came up with a perimeter formula because they gave us the total amount of fencing. Okay, now the perimeter formula didn't give us any squared terms, and we have to have something that looks like an x squared or an L squared or a W squared before we can ever think about doing vertex, right? Because we need an A, B, and C coefficient to be able to simplify this. So then we found an area formula. Area is length times width. So if we could have two W's or two L's multiplied together, that would give us the squared term that we need. So what we did is we took our perimeter formula here and we solved it for L. Now we could have solved it for L or W. I just picked L. Okay, once we have it solved for L, then we just plug that into our area formula, right? And then we have an area formula with just W's. So we went ahead and multiplied it out. Now this gave us an area function, meaning given any width, we can plug it into this and figure out that maximum area, okay? So width goes in, area comes out. So we're going to use our little vertex shortcut here, right, to calculate negative b over 2a, which gave us 40.5. Now that tells us the width we should use if we want to acquire a maximum area, right? But it didn't actually ask us what the maximum area was. So once we had that answer for width, notice we didn't plug it back into the function, right? We didn't calculate this second part of the vertex formula because that would have given us the maximum area. And what we wanted to know is what are the dimensions, okay? So now that we know our width, all we have to do is plug that back in over here to figure out what L is. And I did it up here because I ran out of room. So once we know our width, we just plug it in here and simplify, and that gives us a length of 27 feet, okay? So that's what we did. Let's see if we can do it again. So on the next page, there's another problem very similar. It says, a farmer is building a fence to enclose a rectangular area against an existing wall, shown in the figure below. 3 of the sides will require fencing, and the 4th wall already exists. If the farmer has 184 feet of fencing, what are the dimensions of the region with the largest area? Okay, so let's go ahead and figure out what the dimensions are. Okay, again, it's not asking us for that largest area. If it had asked us for the largest area, then when we're done working it, we would plug it back in, right, to that vertex formula. So let's go ahead and label this one. So here we have 2 lengths. Oh, you know what? Here, let me use, I'm going to use capital L's so that we don't get confused. So here's a length, and here's a width. So this time, our perimeter formula is going to look like 2L plus W, right? And we already know the perimeter because it tells us he has 184 feet of fencing. So that means our perimeter is 184, and this is equal to 2L plus 2W. Okay? And then we also have our area formula, right? We have that our area, or A, is equal to length times width, right? Because this is still just a rectangle. So length times width. Now I want to do the same thing I did in the last problem. I want to be able to solve my perimeter formula for either L or W so that I can plug it in over here in my area formula. Now in this one, I'm not going to choose to solve for L because if you look at this, W is actually a lot easier to solve for in this equation because it doesn't have a coefficient. So I'm going to go ahead and just say this is our easiest to solve for. So in order to solve for W, all we have to do is subtract 2L to the other side, right? So we have W is equal to 184 minus 2L, right? We just move that 2L to the other side. All right, so now that we have what our width is, or formula for our width, we can go ahead and plug it in. So I'm just going to say plug into area. So we're going to plug it in up here for W, right? So now we have A is equal to L times, we're replacing W with what we got over here, which is 184 minus 2L. Okay. All right, so now that we have that, let's go ahead and multiply it. Notice what this is going to give us is a function of area for any L or any length, right? So I'm going to write this as this is the area of a certain length is going to be equal to 184L minus 2L squared, right? Or we can go ahead and rewrite this as, you know, in descending order. So negative 2L squared plus 184L. Okay, just so that we know this is A and this is B. Okay, so because this is a function of area, right, we're looking for the largest area, which means we're going to use our vertex, which is negative B over 2A, and then f of negative B over 2A. Or in this case, we're not using an f function, we're using an a function, right? So what this represents is this is a function that represents when we plug in our length dimension, we get out an area, right, or that maximum area. So we go back up here and notice, just like the last problem, it says, what are the dimensions? What are the dimensions? Okay, so we're not actually finding what the maximum area is. We're figuring out what dimensions give us the maximum area. Okay, so on your homework, it could ask you either or. So make sure you pay attention to that. So the first thing we need if we want to know the dimensions is we definitely need to know length, right? So I'm going to go ahead and do negative b over 2a. So my b is 184. So if I do negative b, I get negative 184 over 2 times my a, which is negative 2. So I get negative 184 over negative 4. And when I divide those two, I get a positive 46. So that means L equals 46. Okay. And notice here it says our fencing is in feet. So that means that our length is 46 feet. Now, what I do with that 46 is dependent on what they're asking for. Okay. So we know that the length dimension is 46 feet. And I can do two things with it. One, I could plug it back into my vertex, right? I could plug this 46 back into my area formula and figure out what that maximum largest area is. Or I could take that 46 and plug it back in over here to figure out my width. Again, because this one is not actually asking us for what the area is, we're just looking for the dimensions, I'm going to take the 46 and plug it back in here. Okay, so I'm going to have W is equal to 184 minus 2 times 46, because we're just plugging it back in to find W. Okay. All right. So now we just simplify this. So W is equal to 184 minus 92. And so we get W is equal to 184 minus 92 is 92. So that means that our length is 46 feet and our width is 92 feet. And those are the dimensions that are going to maximize this area. Okay. All right. So I want to show you a couple of other ones. Pretty much anytime you see largest, smallest, maximum, any of that, you should be thinking vertex. Okay, if you don't see largest, smallest, maximum, minimum, those words, then you might be doing something else with these quadratic functions. Okay, so let's go to the next one and see what it is having us do. So on this one, it says an archer releases an arrow with an initial velocity of 20 feet per second at a height of 12 feet. The path the arrow takes can be modeled using the function f of x equals negative 16x squared plus 20x plus 12, where f of x represents the height in feet of the arrow and x represents the time the arrow travels in seconds. What is the maximum, okay, that's an important word, what is the maximum height in feet reached by an arrow? Round your answer to the nearest hundredth if necessary. Okay, so let's think about this. First of all, they're telling us we have this function, so I'm going to go ahead and just write it. F of x is equal to negative 16x squared plus 20x plus 12. And they're saying that our f of x, or our y value here, right, represents the height, and our x represents the time. So we are plugging in time to get out height. Okay. Now, anytime you see the word maximum, this should make you think vertex. Okay. Vertex. So when we think about vertex, we have a formula for that, right? We have negative b over 2a and f of negative b over 2a. So in this case, when we calculate negative b over 2a, that's going to give us the time it takes to reach our maximum height. And then if we take that time and plug it back in, that will help us to solve for what our maximum height actually is. So let's go back to our problem and see what it's asking us for. It says, what is the maximum height in feet reached by the arrow? Okay, so it's asking us for the height. Now, in order to find the height, we're going to have to first find the time, right? So we can plug it back in. So we're going to have to calculate both here. So in order to find the time, I'm going to do negative b over 2a. So negative b would give me a negative 20 over 2 times a, which is negative 16. So this gives me a negative 20 over negative 32. And that is going to come out to, now since it said I can round to the nearest hundredth, I'm guessing these are not going to come out pretty, but I'm going to try not to round my answer to the very end. Okay, so when I divide these two numbers, I get 0.625. Okay, so that means it's going to take 0.625 seconds for my arrow to reach its maximum height. Okay, so what I want to do now is take this time, and notice I'm not rounding it because time is not my answer. I don't round till I get to the very end. So to find my maximum height, I am now going to plug whatever I got for my time back into my function. So I'm going to do f evaluated at 0.625. And my function says to do -16 times my input squared, so 0.625 squared, plus 20 times my input, so 20 times 0.625, plus 12. And then I just need to simplify this, okay? When I square 0.625 and multiply it by -16, I should get -6.25. Okay, when I multiply 0.625 by 20, I get 12.5. And then when I add all of these together, I end up with 18.25. And notice it did tell me that I could round to the nearest hundredth, which is 2 decimal places. But since this came out to 2 decimal places, I actually don't have to round at all. So this tells me that the maximum height reached by the arrow is going to be 18.25 feet. Okay, so I do want to point out again, you may not have to calculate both of these. If it would have only asked how long will it take for it to reach its maximum height, we would have only had to calculate the negative b over 2a. And when we got here, we would have just said 0.63 seconds, right? We would have just rounded this to 2 decimal places, and that would have been our answer. But because they asked for height, we had to first find time so that we could plug it back in to find the height. Okay? All right, let me look at another one. This one says, a model rocket is launched directly upward at a speed of 28 meters per second from a height of 12 meters. The function f of t equals -4.9 t squared plus 28t plus 12 models the relationship between the height of the rocket and the time after the launch, t in seconds. When, in seconds after the launch, will the rocket hit the ground? So when we're reading through this, I'm just constantly thinking, okay, this is a quadratic. I'm thinking maybe vertex. Now, in order for vertex, we're thinking of a maximum or a minimum or a largest or a smallest. And when we read through this rocket being launched upwards, you know, when I scan this, I'm not seeing a maximum or a minimum reference here. All I'm seeing is when in seconds will it hit the ground, okay? Or the grounds, geez, so many typos. All right, when will it hit the ground, okay? So first of all, let's go ahead and write what this function represents, okay? I have f of t is equal to -4.9 t squared plus 28t plus 12. Okay, that's my function. And t, right, is representing the time after the launch, t, in seconds. So this is giving us our time. And what this function gives us is after a certain time, how high the rocket has gone, right? So time and height, okay? So when we are asked when, that means we don't know the time, right? They're asking us when something happens, we don't know the time. So this is what we want to find, okay? So if we want to find the time, then we should know the height, okay? So it's saying when in seconds after the launch will the rocket hit the ground? Well, when something hits the ground, its height at that moment is 0, right? When something hits the ground, it is 0 feet above the ground. So since we're given the height, that's our y value, right? Or our function value. We know it's 0. So we're just going to set our function equal to 0. So I have 0 is equal to -4.9 t squared plus 28t plus 12. Now this is a quadratic formula, right? Our highest power is t squared. So normally we would think about factoring this. but I don't want to factor with decimals. That's just painful to think about. And so I'm going to use the quadratic formula to solve this. Okay, remember the quadratic formula is t is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm just going to plug in my numbers that I get from this function that I just set equal to 0. Okay, so negative b would give me a negative 28 plus or minus the square root of b squared, so 28 squared, minus 4 times my a, which is negative 4.9, times my c, which is 12, all over 2 times my a, which is negative 4.9. Okay, and then I just keep simplifying. So I get negative 28 plus or minus the square root of 28 squared is 784. And then when I multiply these next three numbers together, I have a negative times a positive. That should all come out positive. And it equals 235.2. All over on bottom 2 times negative 4.9 gives me negative 9.8. And I keep going. So t is equal to negative 28 plus or minus. When I combine my numbers under the radical, I get 1019.2 all over negative 9.8, right? Keep going. Go ahead and take the square root of this as decimals. We're not going to reduce the radical. We're just going to calculate it, okay, and get a decimal. So negative 28 plus or minus. When I take the square root of that, I get 31.9249, and it just keeps going all over negative 9.8. Now, when you're calculating this, we might have to round our answer, and that's totally fine. But when you're working it through, make sure you keep all these decimal places in your calculator so that your answer is completely accurate at the point at which it's okay to round. Okay, so we have two cases here, right? So this tells us that t is equal to negative 28 plus 31.92 all over negative 9.8, or, right, we do negative 28 minus 31.9249, blah, 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 divided by negative 9.8. Okay, so remember when we have a plus or minus, that's giving us two options here. So I want to work out both options. If I do negative 28 plus 31 point mess and divide that by negative 9.8, I'm going to get a negative 0.4005 and some more stuff. When I calculate this next one, I'm going to get 6.1147, da, 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 da. Okay, so let's think about these. So when I look at these, remember we're solving for t. T originally represents time. And notice here I got a negative answer. So I'm not going to use that one because we can't have negative time, right? I can't say it's going to hit the ground after negative half a second. That doesn't make any sense, right? So this is going to be the one that's our answer. And I'm not sure how Newton rounds these. I would say it probably says round to the nearest second or round to the nearest tenth. I'm going to go ahead and just round it to the nearest second. So I'm going to say it's going to take about 6 seconds for this rocket to have gone up and come back down and hit the ground. Okay? Does that kind of make sense? So I wanted to show you one where we're not using the vertex. Okay, remember we only use the vertex if we talk about a maximum, a minimum, a largest, a smallest, that kind of thing. Okay, here we're talking about when it hits the ground, which means we're just setting our function equal to 0 and solving. Okay, all right, and then the last thing I want to throw in this section is x and y intercepts. Now I know we saw x and y intercepts when we were dealing with finding the vertex and putting a function in vertex form, okay? But sometimes we don't even care about the vertex, we only care about the x and y intercepts. And so it's not really necessary to write this in vertex form just to solve for the x and y intercepts. So I wanted to do one example of just given a quadratic function, how to find the x and y intercepts, okay? And remember, to find intercepts, we just set the opposite variable equal to 0 and solve. So if I want to find the y intercept, I just set x equal to 0. So remember, our y is the same as our f of x. So we would get y is equal to, and then I just put zeros in everywhere I see an x. So 12 times 0 squared minus 13 times 0 minus 14. Okay, so I end up with y is equal to negative 14. And then we always have to remember to write it as an ordered pair. So this would be the ordered pair 0, negative 14, right? Because we plugged in 0 for x and we got negative 14 for y. All right, so now let's look at our x-intercept. For our x-intercept, we're going to set y equal to 0. And remember, y is our f of x, so this whole side's going to be 0. So we're going to get 12x squared minus 13x minus 14 equals 0. Now, this one doesn't have decimals or fractions, so you actually could try and do some product here. But because it's larger numbers, I don't really want to do some product. I'm just going to use the quadratic formula. So remember, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And then we're just going to plug in our numbers. So this is my a, this is my b, this is my c. Okay. So x is equal to negative b. My b is already negative, so I'm going to have the opposite of a negative 13, plus or minus the square root of negative 13 squared minus 4 times my a, which is 12, times my c, which is negative 14, all over 2 times my a, which is 12. Okay. So we simplify. This is going to give us 13 plus or minus. I'm going to go ahead and simplify this a little bit faster. When I square 13, I get 169. When I multiply these numbers together, I get a positive 672 all over 24. So this is going to give me 13 plus or minus. When I combine the numbers under my radical, I get 841. 841 is actually a perfect square. So this gives me 13 plus or minus 29 over 24. Okay. So when I work these out, 13 plus 29 is 42 over 24. And 13 minus 29 gives me a negative 16 over 24. Okay. And then I would just go ahead and reduce each of these. Okay. So this gives me 7/4 and negative 2/3. And again, you can use that fraction button on your calculator to help you reduce these. So remember, we're looking for intercepts. So these are ordered pairs. And I'm not sure on Knewton if they have you write them as reduced fractions like this, or if they allow you to write it as a decimal. Okay. So when you get x equals 7/4, we're going to write that as 7/4 comma 0, or, because like I said, I'm not sure if it lets you enter decimals, so just make sure you look at the instructions closely when you do this one. If I do 7 divided by 4, I get 1.75, so this would be 1.75 comma 0. Okay, so those are my first x-intercepts, and then when I do x equals negative 2/3, I could write that as negative 2/3 0, or in decimal form, that one doesn't come out pretty. It's like 0.6666666. So I'm just going to round to 2 decimal places. So 0.67 comma 0. Okay. All right. So on an exam, I will specify how I want your intercepts written. Most of the time we're going to be graphing them, so it's helpful to write it as a decimal so that it's easier to see where to plot that point. But in Knewton, it may have you leave it as a reduced fraction. So I wanted to put both forms on here. Okay. All right. So on the next couple of pages, there are some practice problems for you guys to solve. So I will give you a few minutes. Well, I won't give you. You'll give yourself a few minutes. Go ahead and pause the video, and when you've worked them out, or if you get stuck, go ahead and play it and we'll go over it. All right. So on number 1, it gives us this function talking about the number of new phones they will sell. Okay. Now, it says that the price in dollars, this is the function for just the price, right? But if we want to find the revenue, then we have to take that price and multiply it by how many phones we sell. So that's what they're giving us here, is that the revenue is going to be X times that price. Okay, so our revenue, and I just wrote it as R of X, our revenue is going to be X times the price of the phone. And if we multiply those by distributing the X, we'll get 1,720X minus 5X squared. And then I just rewrote it with the X squared term in the front. Okay, so what this represents is the price of the cell phone, right, at X dollars. And then what we're getting out is the revenue. So let's go ahead and see what they're asking us to find now that we have that revenue function. It says, find the price X, which will maximize, so we're thinking vertex, that will maximize the company's revenue. So they're not actually asking us what the company's revenue is. They just want us to find the price, right? But because we're looking for the maximum, we're going to use our vertex. Okay, and remember to find that first value in our vertex, we do negative b over 2a. So we're going to take the a and the b from our revenue function and just plug them in. So that should give us 172, which means we need to charge $172 per phone to get our maximum revenue on cell phone sales. Okay, does that make sense? Now, if it had asked what is the maximum revenue, then once we find 172, we would plug it back in to our revenue. Okay, all right, let's look at the second one. The second one says a diver jumps up and over from a cliff in order to avoid the rocks and land in deeper water. The path of the diver, goodness, holy typos, can be modeled using, using the function f of x equals this guy, where f of x is the height in feet of the diver at x time in seconds. What is the maximum height in feet the diver will reach? Round your answer to the nearest hundredth if necessary. So anytime I see maximum, I'm thinking vertex. 100% thinking vertex. So I need to know what this function represents. Well, it tells us that x is our time in seconds. So I'm going to put seconds, or you can write time here, okay? And whatever we're getting out when we plug in seconds is our f of x is our height, right? So we're plugging in time or seconds to get out height. So then it asks us, what is the maximum height? Okay, that means we need to know the second value of our vertex. So in order to find that second value, we first have to find the first value so that we can plug it back into the function to find the second value, right? So to find that first value, we do negative b over 2a, which should give you 0.0625. Now, I don't want to round here because this is not one of my answers. It didn't ask me how much time it takes or how many seconds it takes. It just wants to know the height. So make sure you don't round at this step. Okay, so leave all your decimal places, and we're going to take that value and plug it back into our function. So when we plug 0.0625 back into our function, we're squaring it, multiplying it by negative 16, multiplying it by 2 and adding it, and then also adding 48. So once we simplify all of that, we end up with 48.0625. And it said round to the nearest hundredth. So that's our second decimal place. Because there's a 2 behind it, it does not round it up. Okay, so we're going to leave it at 48.6 feet is going to be the maximum height that this diver reaches, which makes sense if you think about it in terms of this problem. If you have a guy standing on a cliff and he's going to try to jump up to kind of jump over that cliff, he's not going to go very high, right? People can't jump really high just from a standing still point most of the time, okay? And it says, you know, here my starting height is 48, right? So I would guess that when he jumps and reaches that maximum height before he goes into the water, it's not going to be much higher than 48. And here, obviously, it's really not a whole lot. You know, he didn't jump too far up to miss those rocks. Okay, and then we want to look at our third one, which was just finding x and y intercepts. Okay, when we find x and y intercepts, we're just setting the opposite variable equal to 0. So here, we plug in 0 for x. We get negative 14. Make sure you write it as an ordered pair. And then to find our x-intercept, we set y equal to 0. Again, you could, you know, potentially solve this by factoring, so you're welcome to try that. Or you can do what I did and just solve it using the quadratic formula. Okay. Once you reduce the two answers that you get, you should get 7/3 and negative 4/9. Knewton may have you enter them as ordered pairs that are written as reduced fractions, or it may have you written that have you write them as decimals rounded to a certain point. So I put both answers on here. And that is the end of this applications of quadratic functions section. Okay, so you should now be able to complete that in your Knewton assignments. And there is also a worksheet that goes with this section. So you have 2 assignments due now that we've completed this section. And that is also the end of Unit 5. So your next test is coming up. If you are in my online class, this is your midterm, which will be taken on paper. So make sure that you have your proctor set up so that I can send the test to your proctor. And if you're taking it with me, make sure you've checked with me and you know where you're going and when. And if you're watching this video because you're in my face-to-face class, you will just be having a regular Unit 5 test in class. Okay? Let me know if you have questions.